So once again, these are the list of rules that you're allowed to use today. In the next video, I'm going to expand upon your toolbox. But for today, I just want you to be comfortable with these 4 rules, okay? So have these rules on your side and refer to them. So before I go into the problems, I just want to make sure that you're going to be using 3 different strategies, mainly 1 and 3 today. So in other words, you're given a problem where you have to prove that the left is equal to right, and you can't just plug in theta is equal to 60 degrees, or theta is equal to 37 degrees, or theta is equal to 42 degrees, something like that. So you have to use these rules axiomatically, and remember that axiom is another way of saying ground rule, or it is what it is. So using the rules that are given to you axiomatically, you can either start with the left side, use the rules axiomatically step by step to get to the right. Or, you know what? You can start with the right side, use the rules, go step by step, and get to the left. Or, my personal favorite, as the proofs gets harder and harder and harder, you would separate the left and the right side. Then you would use the rules step by step to get somewhere in the middle. In other words, the left and right can equal a third option, and that is enough to say that the left is equal to the right. So the first 2 problems, or AKA, they're gonna be done in 2 ways. So 1 and 2 are the same problem, and 3 and 4 are the same problem, and then we're gonna be doing 1 problem each. So for instance, what if I want to use the left proves right method for problem number 1, like we did yesterday? So can we agree that we've got a complicated left and a complicated right, sort of? Okay, so sine of theta times secant of theta is equal to tangent of theta. Okay, so can I do anything if I have my list of rules on the right? I want to transform the left side into proving that it's the right side using my list of rules. Well, is there anything in this list that's going to help me help me break down? Well, I see a secant in the problem, and I know that secant is equal to 1 over cosine. Sine I can't really do anything about other than just make it sine over 1. So sine of theta over 1. Nothing special. But what I can do to secant is make that 1 over cosine. Okay? So all I did was make secant into 1 over cosine. Then I'm just going to multiply across. Sine times 1 is sine of theta. 1 times cosine is cosine of theta. And now I'm left with sine over cosine. Well, looking at the list of rules, you'll notice that even though it's left tangent is equal to right sine over cosine, we can also go backwards. Sine of theta over cosine of theta is equal to tangent of theta. And that's what we wanted all along. So I'm just going to cite my rule over here. So in other words, all I did was say that secant of theta is equal to 1 over cosine. That's what I did on the side. And all I did was multiply across here. And by definition, tangent of theta is equal to sine over cosine. Make that a little bit clearer. Can you see that we did this axiomatically, step by step? Okay. And if you're wondering, what is it that you do when you major in math in college? Even though this is not college level math, it's the same idea. It's going to be like, prove that this ring is isomorphic. It's like, I do not. Prove that this group is commutative. Oh, man. So that's what a proof is. You list the rules and you manipulate it axiomatically, as opposed to plug it in. Oh, it works for 30 degrees, so it works for all of them. That's not how it works. So let's say I do this problem in another way. I personally would do left and right are separately. Left and right are separate. They're going to meet somewhere in the middle. So right off the bat, if I were to approach this as a high school student, I've got complicated left equals complicated right. You notice that in yesterday's lessons that the right side was 1, and that meant that I can't really make 1 any less complicated. It's just 1. But tangent of theta can be broken down into sine of theta over cosine of theta. Okay, so let's end it there for the right side. Okay, and then sine of theta, secant of theta. Well, I can't really do anything with sine of theta. I can just make the sine of theta over 1. Secant of theta, well, I can manipulate that. Secant of theta is 1 over cosine of theta because it's a reciprocal trig function. And now I'm going to multiply across and make this sine of theta over cosine of theta. So, hey, the left leads to somewhere in the middle, and the right leads to somewhere in the middle. Therefore, the left is equal to the right. I personally would prefer to do it this way because I don't like complicated left and complicated right. I would prefer simpler left and simpler right. This is a thorough proof because if the left and right both lead to sine over cosine, that's what's called the transitive property. If left is equal to the middle and right is equal to the middle, therefore left equals right. Okay, let's take a look at problem number 3 and 4. They're the same problem. I'm going to do cosine of theta, cosecant of theta is equal to cotangent of theta. See which one you prefer. Left and right meet in the middle, or left proves right. Okay, so let's say I like the left and right meet in the middle approach. So, for instance, the left side is cosine of theta, cosecant of theta. Okay, and the right side is cotangent of theta. I've got complicated left equals complicated right. I'm not a fan of that. What I do know in my list of rules is that cotangent of theta is 1 over tangent. So, you know, even though that rule is useful, I kind of like the bare basics of trig proofs. If I can break it down into cosine over sine, you know, I'm happy. So by definition, cotangent is 1 over tangent, or cosine over sine. Okay, hopefully the left side can be broken down into cosine over sine. Well, can I break anything down for cosine of theta, cosecant of theta? Well, cosine can be just cosine of theta over 1. Okay, nothing really helpful there. Well, cosecant is 1 over sine of theta. Okay. Well, cosine times 1 is cosine. 1 times sine is sine. So the left leads to cosine over sine. The right leads to cosine over sine. This is a thorough proof. Because if the left leads to cosine over sine and the right leads to cosine over sine, this is enough information to say that the left is equal to the right. Therefore, cosine of theta, cosecant of theta is equal to cotangent of theta. Okay, but that's not the only way you can do it. I'm sure there's multiple ways to do it, but the two that come to mind are left and right meet in the middle, or left proves right. So I'm going to use the same idea. Can I break down cosine? Not so much. Cosine of theta over 1. And I can rewrite cosecant of theta. All right, I'm just going to make a little note to myself. You don't have to do this with color. That cosecant of theta is the reciprocal of sine, so 1 over sine, by definition. I'm going to put it together. Cosine of theta times 1 is cosine of theta. 1 times sine of theta is sine of theta. So now I'm left with cosine of theta over sine of theta. I'm going to look at my list of rules, see if anything can be helpful. Hey, I've got cosine of theta over sine of theta, and that ends up being cotangent of theta. So that works. All right, now I'm going to do 5, 6, 7, 8, and I'm just going to pick a method. Okay, personally, I like left proves right because if I've got complicated left and complicated right, I'm not happy. Okay, so I just want to clarify something. So this is called cosecant squared of theta. Don't be afraid of it. If we square a number, that means we multiply it by itself. So for instance, 3 squared would be 3 times 3. So cosecant squared is cosecant of theta times cosecant of theta. So let's just ease our anxiety there. So the left side is cosecant squared of theta, tangent of theta, complicated left, and I've also got complicated right, cosecant of theta, secant of theta. Okay. All right. Well, I can rewrite this cosecant squared of theta. I can write this as cosecant of theta, cosecant of theta. Okay. Now the reason why is because I'm just using the definition of squaring. Okay. And now I'm going to break this down even more. Well, cosecant by definition is 1 over sine. So why don't I break this down into 1 over sine times 1 over sine. Okay. Where's my big fancy multicolored pen? There we go, I found you. And I'm going to break down tangent. Well, since we're all breaking it down into cosine and sine, I can break down tangent into sine of theta over cosine of theta. And now I'm going to put it all together. So I've got sine of theta on top over sine of theta, cosine of theta on the bottom. Well, let's just check in with the right side really quick before we forget. Okay, can I manipulate cosecant? Using my list of rules, can I manipulate cosecant and secant? Well, using my list of rules for trig proofs, cosecant is 1 over sine, and secant is 1 over cosine. So let me just, cosecant is 1 over sine, and secant is 1 over cosine. So I'm just going to multiply across and get 1 times 1 is 1. Sine times cosine, well, I can't really do anything about that. That's sine cosine. Okay, now I'm going to check back in with the left side. Can I do anything about sine over sine, cosine? Yeah. In fact, what I can do is cancel out one sine on the top and one sine on the bottom. And that leaves me with 1 over sine cosine. And on the right, I got 1 over sine cosine. Hey, the left led us to 1 over sine cosine, and the right led us to 1 over sine cosine. So therefore, since the left and the right are equal to each other, this proof checks out. The more practice you get with this, the stronger you'll be in Algebra 2. Because Algebra 2, oddly enough, requires a few proofs. And this is just algebra. I know it seems like gibberish that we're using sine, cosine, tangent, cosecant, secant, and cotangent. But this is going to strengthen your skills for Algebra 2. See if you can do secant squared of theta times cotangent of theta is equal to cosecant of theta, secant of theta, axiomatically. So the left side has secant squared of theta times cotangent of theta. I've got a complicated left, and I've got a complicated right. So I've got the right side is cosecant of theta, secant of theta. Okay, so let's find some common ground here. I don't like complicated left and complicated right. I would prefer if complicated left met somewhere and complicated right met somewhere. So I'm going to rewrite this problem. Secant squared, I can write this as secant of theta, and I've got cotangent of theta. Okay. Actually, you know what? I'm going to start with the right side. So cosecant of theta is going to be, all right, using my list of rules, cosecant is 1 over sine. And secant is 1 over cosine. And now I'm just going to put it together. 1 times 1 is 1. Sine times cosine, that's sine of theta, cosine of theta. So once again, I'm going to get something similar to the previous problem. In other words, I'm hoping that the left side will also lead us to 1 over sine cosine. So what do we got here? Well, secant squared is equal to secant times secant. I just broke that down. Well, I can break down secant into 1 over cosine. Sorry, let me get my green. So secant is 1 over cosine. Secant is also 1 over cosine. And I'm going to break down cotangent. Well, I like it when it's all built on the basic building blocks of sine and cosine. So cotangent is equal to cosine over sine. Okay, now I'm just going to put it all together. 1 times cosine is cosine of theta. Cosine times sine. Okay, can anything cancel out? Yeah, a cosine on the top and a cosine on the bottom. So that leaves me with 1 on the top and cosine times sine on the bottom. And I'm not so hardcore. I know that it says 1 over sine cosine on the bottom. 1 over sine times cosine, and the left side is 1 over cosine times sine. I'm not that hardcore. We know that the multiplication is commutative. In other words, we can flip the numbers and we'll still get the same product. So this is a proof of how the left and the right are equal to each other. Okay, I'm going to cut it off right here because it's been a little bit under 20 minutes, so I just want to make sure you guys can digest this okay.